So in this video, we're going to have a look at multiplying radicals. So to start with, we're going to look at the question here: does root 4 times root 9 equal root 4 times 9? Well, let's look at this. So root 4 times root 9 equals root 4 times 9. We know that the square root of 4 is equal to 2, and the square root of 9 is equal to 3, and 4 times 9 is equal to 36. So 2 times 3 equals 6, and the square root of 36 is equal to 6. So therefore this is true. Root 4 times root 9 does equal the square root of 4 times 9. So this question here worked out rather nicely because we have nice perfect squares here of root 4, root 9, and root 36. Let's look at this question now. Does root 5 times root 7 equal root 5 times 7? This guy's going to be a little bit, not trickier, but just a little bit messier because we don't have perfect squares to deal with. But we can use our calculator to have a quick little look and see whether or not this appears to be equal. So we have root 5 times root 7 equals root 5 times 7, which equals root 35. Open up our calculator, have a look at this. We have root 5 times root 7. So if we do the square root of 5 times the square root of 7, this equals 5.916. So 5.916. Right? That's been rounded off a little bit, but for the purposes here, we'll see that it's not going to make a big difference. And we have equals the square root of 35. So the square root of 35, 5.916. Right? So again, we've shown that it looks like root 5 times root 7 is equal to the square root of 5 times 7. Now we've done some rounding there, which makes things a little bit difficult. But we can prove this, right? We can prove that root 5 times root 7 is equal to the square root of 5 times 7. Now, one important thing to remember is that we can do whatever we want to this, so long as we do not disobey this equal sign. So what I'm going to do is I'm going to square both sides of this equation. Right? Now this is going to give us the square root of 5 times the square root of 5 times the square root of 7 multiplied by the square root of 5 times the square root of 7. Just been squared, right? This equals the square root of 35 all squared. Now, rearranging this slightly, we get root 5 times root 5 times root 7 times root 7 equals root 35 all squared. Now, with our knowledge from the previous lesson on exponent laws, we know that we can write this as 5 to the 1/2 times 5 to the 1/2 times 7 to the 1/2 times 7 to the 1/2, which equals 35 to the 1/2 all squared. And with further exponent laws, we know that same base, add the exponents. So 5 to the 1/2 times 5 to the 1/2 becomes 5 to the 1. And 7 to the 1/2 times 7 to the 1/2 becomes 7 to the 1. And here we can know that we can multiply the 2 times the 1/2, and we get 35 to the 1. 5 times 7 is 35 equals 35. So we know that root 5 times root 7 is in fact equal to root 5 times 7. So this is handy as it shows us that we have this nice little law here to use. We know that the square root of a times the square root of b is equal to the square root of a times b, where a and b both must be greater than 0. We know that with the square roots here, we cannot have a or b be a negative value, right? So a and b must be greater than 0. So let's use that little rule looking at this guy here. So keep in mind that when you see something like 3 root 3, there's actually a multiplication sign in between here that is implied. It's just not written. So in this question here, we're really saying 3 times root 3 times 2 times root 5. And we know that with multiplication, the order doesn't matter. We can rearrange this and change the order to be 3 times 2 times root 3 times root 5. And we know that 3 times 2 equals 6. And we've shown that root 3 times root 5 is equal to root 3 times 5. And we get 6 times root 15. Right? So, next one. We're being asked here to express root 21 as the product of radicals. So we want to write it as two radicals that multiply together to equal root 21. So we're kind of using the reverse of our rule we just showed. So root 21 we know is equal to root 7 times 3. And with our rule we know that the square root of 7 times 3 is equal to the square root of 7 times the square root of 3. This might seem kind of trivial, but it's going to be very useful for the next little part where we're going to be looking at writing radicals as mixed radicals. So in order to do that, we need to understand what an entire radical and a mixed radical are. So for example, root x would be an entire radical where everything is written under the radical sign, whereas a mixed radical is a combination where you have some under the radical sign and some outside. So for example, the square root of 108 would be an entire radical, while 2 times the square root of 6 would be a mixed radical. So here we're being asked to express root 45 as a mixed radical. So the first step is to look at root 45 and think, what multiplies together to give me 45? Well, for me, 9 times 5 comes to mind. Right? 9 times 5 is 45. So the square root of 45 is equal to the square root of 9 times 5. And we know from our previously that we've shown that if we're multiplying radicals, the square root of 9 times 5 is equal to the square root of 9 times the square root of 5. And it's quite clear that the square root of 9 is equal to 3 times root 5. So now we've expressed the square root of 5 as a mixed radical, 3 root 5. Next example, square root of 20. So again, what multiplies together to give us 20? Well, I think of 4 times 5. Therefore, root 4 times root 5. Root 4 is equal to 2 root 5. So the square root of 20 is equal to 2 root 5. We've expressed root 20 as a mixed radical. Last one. Square root of 72 is equal to 9 times 8. Right? 9 times 8 is 72. So again, this is root 9 times root 8. Well, root 9 is equal to 3 root 8. So 3 root 8. You might think that you're done here, but actually, if we think about root 8, it can be split apart as well. So we could write this as 3 times root 4 times 2, which is equal to 3 times root 4 times root 2. And we know that the square root of 4 is equal to 2. So we get 3 times 2 root 2 and 6 root 2. All right? Now to me that means that I did 2 steps, which means that I could have probably chosen different values earlier and sort of saved myself a little bit of work. And if we think about that, let's look at root 72 could be written as the square root of 36 times 2, right? 36 times 2 is also equal to 72. Well, the square root of 36 times root 2, we get 6 root 2, which is the same. All right, so both methods work. Just always make sure that you check your final answer to see if it can be simplified further. So there's some examples that we've done. Now I want you to try. There's 4 questions here. Try what you've learned in this little lesson to